Now that we have seen how we go about working with the data types of variables, something that's very interesting that TypeScript adds to the language is the concept of interfaces. Interfaces deal with the the concept in many languages called duck typing, duck types. So what duck types do is that we are going to check the shape of variable. So what I'm going to do is take an example here of a function. Let's say we have this function called function is tasty. It takes a fruit object, and we basically do is if fruit dot taste not equal to bi bitter. In that case, we return true, else we return false. Okay, so looks like a very simple function out there to me. It tells you if a fruit is tasty or not, depending on if it's bitter or not. Okay, now duck typing is basically trying to figure out what the shape of this variable fruit is going to be like. And if I want to make sure that when somebody is calling this function is tasty, if I call like console.log is tasty um, on a variable, let's say I'm going to do let mango equal to, and mango has taste say sweet, and then I'm going to do let apple equal to an object where it has color red. Okay, now you see that mango, and I'm going to do console.log is tasty on apple. Okay, now you see the problem here is going to be, of course, that fruit.taste does not exist inside apple, but it does exist in mango. So here we want to make sure that the variable that's coming in, the variable called fruit, is going to be of a particular data type that contains the variable taste inside it. Okay, so let's go ahead and see. I'm going to write here fruit, and I'm going to create an object as a data type here, and I'm going to write that it's going to have taste, which is going to be of type string. Okay, so as soon as we do that, you will start noticing that what happens is we get a red underline here on Apple, and the error that we get is that argument of type color string is not assignable to parameter of type taste string, which means that Apple needs to have this taste argument, a taste parameter inside that. So if I write taste sweet here, and now it becomes acceptable to this function. Okay, so this that we did here is called basically an interface, and although we did not explicitly use the word interface here, if this the data type of fruit becomes overly complex, then writing that inside the function definition is just gonna make the function definition really long. So instead of doing that, what we do is we create an interface. We write interface fruit, which has taste as string, and then we say our fruit is of this data type fruit. Okay, so we use fruit as an interface and data type. Okay, and there we go. Now the benefit of this is going to also extend to just creating objects as well. Now if I want to create an apple of type fruit, I can write here apple colon fruit, and I start getting an error right here, is that this apple object cannot be assigned into a fruit object because it does not have the taste variable. Now if I add taste and I add some taste into it, say sweet. Now when I'm using an explicit interface with the Apple object, it is not only going to check whether the required keys like taste exist or not, it's also going to check if there are any excess keys which it's going to prevent me from writing. So if I say apple is of type fruit, then I have to exactly match the structure that I have defined inside my interface. So that's why interfaces help us. We can assign an object, we can assign an interface to an object, and then TypeScript will make sure that my object is exactly of the same data type. We can assign an interface to a function variable, and it makes sure that the argument that it receives is of the type that it needs. Okay. So I think that gives you a good idea about what interfaces are. We can, deal with interfaces a little more in depth later on, where there are some other features about interfaces which we can discuss. But this should give you a basic overview of what interfaces are and what is the purpose of using them.